This is actually our last lesson in chapter 7 here. So yesterday we learned about all different kinds of polygons and these cool formulas that work with any type of polygon out there. You can figure out the sum of the interior angles, and we know the sum of the exterior angles, right? Other than that, then it's a little bit tricky, except if we have what we call regular polygons. So that's what we're going to focus on for our last lesson of chapter 7 is regular polygons. So you're probably asking, what the heck is a regular polygon, right? Well, regular in mathematics means all sides are congruent and all angles are congruent. That's what the word regular means. All sides congruent and all angles congruent. Now we know what a regular triangle looks like, right? So if I were you, draw the triangle. I know it'll be quick. But we would call this an equilateral triangle, right? An equilateral triangle is a more special way of saying a regular triangle because it has all sides congruent, sides imply angles. Technically, I guess you could call it an equiangular triangle as well because we have those theorems about sides imply angles and the opposite. But more often we think of it as an equilateral triangle. That's a regular polygon. What about a quadrilateral that has all sides congruent and all angles congruent? Both, right? It's got to be both. If all the angles are congruent and all the sides are congruent, we call that a square, right? Now, all the other polygons, we haven't analyzed quite as much as we have our triangles and our quadrilaterals, right? And not as many cool things happen with all those bigger polygons. So other than that, if I have something like this hexagon here and all the sides are congruent and all the angles are congruent, then we just call this a regular hexagon. And that works with any of the other shapes, a regular heptagon, a regular nonagon, a regular decagon, etc., right? You just put the word regular in front of it, and that tells us that all the sides are congruent and all the angles are congruent. Now, if we have all sides and all angles congruent, we can have some more interesting formulas that go along as well, right? So here I have the same three shapes. But this time, I would like you to go ahead and draw in your exterior angles, just like we did yesterday in our notes, right? So let's go ahead and draw in our exterior angles on each of these. The hexagon gets a little bit more interesting, but we can do it. There we go. Okay. So yesterday we used these shapes and we kind of figured out what the sum of the exterior angles would be, right? But I want to know what would be the measure of one exterior angle. Now, we're saying that these are regular polygons. So this time we know that all the sides are congruent and all the angles are congruent. So you can go ahead and mark your pictures that you know all of these angles are congruent. And in this case, the sides aren't quite as big of a deal because we're talking about angle measures, right? So we're really just focusing on the idea that all the angles are congruent. The sides will work as well, right? Okay, so think about it. How would I figure out the measure of one single exterior angle? You could go it the long way, or you could go maybe find a shortcut. So see if you can pause your video and see what you can fill in here on your own. All right, so if I have my equilateral triangle, I know that all the angles are 60 degrees. And if I know the interior angles are 60, then I know the exterior angles are 120, right? All right, so we knew that. We also know our quadrilateral here, right? All the exterior angles would be 90. And I know my hexagon. Now here's the hexagon. This one's a little bit trickier, right? I don't really have that one memorized. I don't know what those interior angles are. So let's see if I can't find a shortcut by looking at my other two to see if it works over here on this one. So let's see. what I was doing on my triangle and my quadrilaterals, I was finding the sum of the interior angles and then dividing by how many there were, right? So if I have my hexagon here, I could find the sum when n equals 6. So S sub I is 6 minus 2 times 180. This is our formula from yesterday that we learned, right? So I have 4 times 180, which would give me 720 degrees. So if I know that all the angles add up to 720, then I would do a little, okay, 720 divided by 6, since there's 6 of them, which would equal 120 degrees. So each of these would be 120. And if the interior angle is 120, that means that the exterior angle would have to be 60. All right, well, I got there. That seems like a lot of work, though. What did we learn about the sum of the exterior angles yesterday? We learned that the sum of the exterior angles, S sub E, is always 360, right? So if I know that the sum of the exterior angles is 360, and if they're regular, they're split up evenly by however many there are, right? So if I have my triangle, I would take this 360 degrees, and I would divide by 3, because there's 3 angles, and I would get 120. If I have my quadrilateral, I have my 360 degrees, and there's 4 of them this time, so I would divide by 4, and I would get my 90. So I could have done the same thing here with my hexagon. I could take my 360 degrees, and I could divide by 6 this time, and there is my 60 degrees that I get, right? And that's a lot faster than having to find the whole sum and divide by how many there are and then subtract from 180. Boom, here's my shortcut, right? So for all regular polygons, now this only works because we know every single angle is exactly the same measure. So for all regular polygons, I have a formula that says E equals 360 divided by N. So E stands for the measure of one exterior angle. That's what the E stands for. So one exterior angle is 360 divided by N, where again, N is the number of sides. So here is another very important formula. So make sure that you write that one down, put a box around it, put a star around it. And again, this only works for regular polygons, because if it's not regular, if all the angle measures are different, there's no way I can figure out what each one measures, right? So the measure of one exterior angle of a regular polygon is 360 divided by N. The sum is always 360 divided by how many there are. All right. Here's your next problem, and that says to find the measure of each interior angle. Each interior angle of a regular octagon. So I do know that this octagon is regular. So I know all the angles are congruent. Why don't you pause your video, see if you can't figure this one out on your own. All right, now there are 2 different ways to do this. So I'm going to kind of split my space over here in half so I know that I don't kind of overpower anything. So one way would be, can I figure out the sum of all of the interior angles and then divide by how many there are, right? So if I have a regular octagon, that means N equals 8, right? So I could start by saying, all right, sum of the interior angles is N minus 2 times 180. In this case, my N is 8. So I have, okay, sum of the interior angles would be 6 times 180, which means the sum of the interior angles is 1080. So that's all of them together, right? So all of them together is 1080. But I know that there's 8 of them, right? So that means one interior angle would be 1080 divided by 8. The 1080, 1080 came from what we just figured out, right? So 1080 divided by 8 gives me 135 degrees. So that works, right? That's definitely one possibility. So my formula here for this one would be, whoops, I missed it. My formula would be I equals S sub I over N, but S sub I takes a little bit of work unless they give it to us, right? So S sub I over N would be N minus 2 times 180. Can't squeeze it in, sorry. N minus 2 times 180 divided by N, right? So that's definitely one possibility. I'm going to write it up here. Just so you can see it a little bit better. But that's not the only way to do it, right? Did anybody use the formula that we just learned in the last one? So that formula said that E equals 360 over N. So I could figure out one exterior angle, right? And then I know that the interior angle, I just have to subtract from 180. They form a straight line. So that means that I could do E equals 360 divided by 8. 360 divided by 8 equals 45 degrees. So that means that I know an exterior angle is 45 degrees, which means, there we go, that to find the interior angle, all I have to do is subtract from 180. So 180 minus my interior angle of 45, right? So that would give me 135 degrees, exactly what I just found from my other method. So this is another way that I could do it, similar, well, you know, finding the same thing, but a totally different formula, right? What I did here is I did 180 minus E. Now, they don't always give you an exterior angle, so we could say that it's I equals 180 minus 360 over N, right? Because the sum of the exterior angles is always 360. So this one could be 180 minus 360 over N. So we have two possibilities for our measure of one interior angle. That's what I stands for, right? Measure of one interior angle. And again, this only works for regular polygons because otherwise they're not all the same measure, so you can't find the measure of any of them. Okay, but we have two possibilities, so make sure you write down both. Put a big box around both of them, put a star next to it. There's your two formulas now to find the interior angle. So we now have all kinds of awesome formulas, right, that we could use. So let's practice figuring out which one would I do here. Find the measure of each interior angle of a regular 100-agon. Pause your video and see what you can do. So 100-agon means there are 100 sides. Now this is each interior angle, right? So I could use either one of my formulas that we just talked about. So I think one of these is going to be fast and one of them is not going to be so fast. So I have one option is 180 minus 360 over N, right? The other option was N minus 2 times 180 over N. Okay, so over here, I have, let's go back here. So I have 180 minus 360 divided by N is 100. Ooh, this is looking easy. I can do this, right? Oops. I equals 180 minus 3.6. Maybe need a little calculator there, but that should be easy enough to figure out. I equals 176.4 degrees. Boom, right? Fast. All right, now how long would it take me to do this method? All right, I equals, let's see, N minus 2 times 180 over N, that I know N is 100. Okay. Oh, 98 times 180 over 100. Oh my gosh, that was definitely a calculator problem, right? All right, 98 times 180, when I type it into my calculator, I get 1,764 divided by 100. That's actually easy enough to do. Okay, so that would give me 176.4 degrees. Same thing, right? One way was faster, but both ways work. So you could do either one. You didn't have to do both. But you can, I just wanted to show you, no matter what number of sides you have, whichever formula you want to use will work out for you. So if you want to remember both so that you can find the fastest way, like in this case, or if you just want to really focus on just one of them and then just, make sure that you know that sometimes you're going to be spending more time doing more work, right? So there you go. All right, so we have two new formulas in this lesson, three technically, right? First one was the measure of one exterior angle, E equals 360 over N. And then the second and third were the two different options for the measure of one interior angle. And remember that these have to be in regular polygons only. The ones we learned yesterday were for all polygons. Each individual angle measure has to be in a regular polygon because they would all be different otherwise.